Hello everyone, let's jump into wireless LAN operations. This is wireless local area network operation. And to get started, we need to talk about two different types of modes. We're going to hit infrastructure mode and then we're going to hit ad hoc mode. First, with infrastructure mode, we're focusing here on a wireless network that's connected to wireless devices. But that wireless network connected to those wireless network devices is hooked to a wired distribution system. What that means is our wireless router is connected with a wired Ethernet cable down into our infrastructure. That infrastructure of these other two switches here will then carry that traffic on to the router and to the local PCs. You're literally connecting your wireless router with a wireless device, and that wireless router is then having a wired connection to your distribution system. Let's switch over to ad hoc mode, much more basic. And with ad hoc mode, we're talking peer-to-peer. We've got two devices connecting wirelessly without any network infrastructure, without any wired distribution system. A good example of this would be having two phones and literally having two phones directly connected to each other, maybe sharing a file using technologies with Bluetooth or AirDrop, 802.11 coming into play there. But that would be ad hoc. You do not have an infrastructure device. It is directly device to device, known as peer-to-peer. Lastly, you could toss this in as like a extra mode, but this would be tethering. And with tethering, this is where you have a cell phone or a tablet with cellular data access connecting to cellular internet. But that cellular device is also running as an access point. We would call that as a hotspot. So while the cellular device itself is having a connection to the internet, it is also creating a wireless signal for wireless PCs, wireless tablets, and other devices to connect to the phone or tablet that's running cellular as a wireless route. From there, our devices that do not normally have cellular data access, they can connect through that cellular data device, and that's called tethering. It really is similar to ad hoc, where we're going to be using a peer-to-peer from our, let's say, laptop or from a non-cellular data device with this cellular device, and then that cellular device itself will connect out to the cellular data network. So it's time to switch it up a little bit. We're going to add a couple new terms here like BSS and ESS. So let's dive right in. BSS is Basic Service Set. And Basic Service Set is where we talk about providing wireless access to small deployments. A Basic Service Set will include a BSA, known as a Basic Service Area. These yellow bubbles, for example, are basic service areas. That is the extent of the wireless signal that is possible to connect to with that access point that we see here. The BSS ID is the Basic Service Set Identifier, and that's going to be the layer 2 MAC address of your access point you're connecting to. So here's one access point, and that's the BSS ID, which is what you'd be connecting to inside of your basic service area with a laptop in that signal range. Here's another signal range, or BSA, Basic Service Area, and there's a separate access point, and that access point has its BSS ID. That's the formal way that we recognize the access point, which again is the layer 2 MAC address of that access point. Now the thing is, this doesn't scale. And if you're talking about larger networks and scalability, we're going to flip over here to the ESS. With the ESS, known as the Extended Service Set, we're going to have one huge, large area of coverage. And that large area of coverage that we're going to be seeing here is going to be based off of having multiple BSAs, or Basic Service Areas, deployed. But they're deployed in such a manner that they're all connected to one single wired distribution system. So we have multiple access points, each access point having its BSS ID, with devices connecting to those access points, and those access points being connected to that wired distribution system. And the cool thing about this is it promotes roaming, which means this user over here on the far left side in this BSA can take their laptop and walk over into another office and hook to another access point on the same wired distribution system. And with roaming, it would be seamless for that user. They don't have to disconnect from one wireless SSID and connect to another one. It will be seamless. So let's continue on through our conversation. As we connect to these access points, what do we have to worry about? Well, you usually don't have to worry about this, but at least it's something to learn. And that's called 802.11 frame structure. We're not going to rip it apart, but we can talk about it. This 802.11 frame is similar to what we've seen in 802.3 Ethernet, and that's frame, but we've got more fields. We've got here frame control, duration, multiple addresses, sequence control, and then even an address for it. What it comes down to is we have to concern ourselves with how our devices are going to be connecting to an access point or a wireless router, and that might be the middleman in our conversation to eventually have this traffic reach a web server on the internet like Cisco.com. So we have this middle device to work through. Well, how do we do that? Well, with these different fields inside of this frame structure, we can use things like address 1, where address 1, for example, would be the MAC address of the receiving wireless access point. Address 2, for example, would be the MAC address of the transmitting wireless device, like your cell phone or a tablet or the laptop you're on. Address 3 might even be the gateway device. This might be the router that's going to be the default gateway of the network. Think of all the different devices that your wireless client will have to get through to eventually leave its local area network when you're referring to having wireless and this wireless technology in the middle. We have control sequencing and fragmented frames coming up in the sequence control. Address 4 could be used in our ad hoc modes. In frame control, we have to worry about power management and subfields for different protocol versions and frame types. And finally, don't forget this big, huge area of payload. Payload is the data of your transmission. And then FCS for our frame check sequence, that's your error control. So all this comes into play to help us connect out with our wireless end devices. And speaking of wireless end devices, feels like there's a constant battle because everything is going wireless and it all wants to fight for bandwidth. Well, how do we gain access with many wireless devices to a single wireless access point? Well, there's a technology that's going to help us out, and that's called CSMA-CA. CSMA-CA is Carrier Sense Multiple Access Collision Avoidance. And really what this means is we're not going to allow traffic just be colliding into each other, flying through the air as all these different laptops and smart devices are trying to interconnect across an access point. We have a better way to go about it. With Carrier Sense Multiple Access Collision Avoidance, if you slow that down and speak it a couple times, that's really what's about to happen. What do I mean by that? Carrier Sense. We're going to listen to the wireless media. Multiple access. We have many devices that want to use the same media at the same time. Collision avoidance. We're going to make sure they don't all ram signals into each other and then corrupt that signal. So what does that mean in the most basic sense? We're going to have our wireless devices listen to the wireless channel and see if it's idle. See if there's no other traffic currently on that wireless channel. That channel is just called the carrier. We're then going to have the RTS. Your end device, your computer, your PC, the laptop, the tablet, it's going to send a RTS. And this is a ready to send message. That message will be heard by the access point. And the access point can then provide dedicated access to the network. Well, how does the end device know that the access point is ready? The access point will respond to that RTS, the ready to send. It'll respond to it with a clear to send, a CTS. It says, the dedicated access is ready for you. Go ahead and send. When the wireless end device hears that, it's going to then send and transmit its data. And by the way, all of our wireless transmissions are going to be acknowledged. And if the wireless end device does not receive an acknowledgement back, then it knows there was a collision. And it's going to restart that entire process back from listen. In order for us to first communicate with a wireless network, though, we do have to associate with a wireless access point or wireless router. And all associating means is we need to agree on specific parameters being used by these wireless network devices, as in the wireless access point or wireless routers. So how it works is this. Our device is going to try to communicate on a specific SSID, which is your wireless network name, with a password, and then using a specific network mode. For example, the wireless router or wireless access point might be supporting 802.11a, b, g, N, AC, or AD wireless LAN standards. Your device has to agree to use that standard in order to communicate with said wireless router or wireless access point. Now, some wireless routers and access points can support multiple standards at the same time, and that's known as mixed mode. Besides agreeing on the mode to use, your wireless end device also has to agree on the security, and that could be your WEP, WPA2, WPA, along with the encryption standards of TKIP or AES. When you have agreed on using the correct one with the access point, hey, those are agreeing on parameters. And lastly, we have radio frequencies, which are our wireless channel settings. We need to make sure that we have an appropriate channel set with our wireless router and wireless access point, and our wireless clients will connect on that. When all that has been done, then we can successfully say we've associated with a wireless access point. Now, when we talk about associating with wireless access point, it's usually very easy. You go on your wireless client, you'll click refresh to see the wireless networks nearby, and you'll hear about them. You'll hear about the name of them, which will be the SSID. You'll hear about the standard supported, which will be the 802.11 standard used. And also you'll hear about the security settings in place that access point or wireless router requires. All of that's being provided via a beacon. The default, standard, easy access wireless mode is known as passive. In passive mode, wireless routers and access points are on time intervals when sending out beacons, and the beacons includes all that information. But there's another mode, and it's called active. And in active mode, our wireless client, well, there's an issue here. The wireless client isn't going to hear a beacon being sent by default by an access point. And what needs to happen in order for a wireless client to successfully access the wireless network is we have to manually configure the SSID and the supported standards on the wireless client. And when the wireless client has the wireless network name on it, which is the SSID, and it has the correct standards to use configured on it, only then are we able to gain access to that wireless router or wireless access point. So the easy way, that's passive, that's the default. The more difficult way of connecting to network would be using the active mode. So take your time, read through the material for wireless LAN operation, and enjoy picking up some awesome wireless skills.